Hello guys, welcome to Null Void. Today we're going to look at a problem called word search. It's a problem being asked in interviews of companies like Amazon, Google, Facebook, Microsoft, Uber, Apple. So let's look into it. The problem description says that given an m cross n grid of characters board and a string word, return true if word exists in this grid. The word can be constructed from letters of sequentially adjacent cell, where adjacent cells are either horizontally or vertically neighboring. The same cell may not be used more than once. So we have a grid, we got a word, we need to find if that word exists in this grid. We can move horizontally, we can move vertically, but we cannot move diagonally, and we cannot repeat a word, repeat a character in the grid. So looking at example 1, this is a grid and this is a word, and we need to find out if this word exists in this grid. So we see A, B, C, C, E, D exist in this grid, so that is why we return true. Let's say the word was A, B, C, C, E, F, then we'll return false because we cannot move diagonally. So if you remember one of the problem that we have solved earlier called number of islands, we had a similar situation there where we had to find the number of islands that were there. We can use a very similar approach here using DFS with some changes, where we will check in this grid where can we find our first character. When we find it, we will write a DFS function where we will check in all the direction if we can find the next character. So let's say we found A, we try to find B in the neighboring cells of A. We see that we got B. Now, as it is a DFS, then that means we will first process one branch entirely, then we'll go to another branch. So for B, we try to find C in its neighboring cell. We found C, and at the end we found D, and we found the entire word. So we can return true from here. That is how a solution will look like. So let's start the solution. First, we need to iterate through this grid to find out the first character in our word. So let's iterate through it. 0 less than equals to board dot length. So that's how you iterate a matrix in Java. So now we have our for loops ready. What do we do next? We need to check if the current character that we are seeing in this grid is it equal to the first letter of this word. So we need to write a if condition where board of I j j board of ij double equals to word dot char at 0. That is the first word. If this is true, we'll run a DFS function to check if we can find our entire word in any of the branches. So let's call our DFS function as word search, and we need to pass it our grid that is called board, and we need to tell it the word that it needs to look at, our current position, and count is basically which character in this word are we going to check. So if this is true, then we can return true from here because we found the word. Otherwise, we can keep on iterating to check if the word exists in this grid. If we did not find any case where we can find the entire word, we can just return false. So this was the structure of our problem. Now we need to write the DFS function, which is basically the juice of this problem. So let's write our DFS function. Let's make it private. It can return boolean to say if it found the word or not, and we name it word search. What are we passing it here? We are passing it the board. It's a 2D board, and we are passing it a word. We are passing it the current coordinates, that is the current location in this board, and the count. Count is basically how many words we have seen and what is our current word. At first we need to check if count equals to word.length. If that is true, that means we have found the entire word and we can just return true. So in that case, if count double equals to word dot length, then do what? Just return true. If this is not the case, then we need to check if the letter that we are looking for is it in any of our neighbors. So before doing that, we should check if the ith and jth location that we are trying to look in this board, is it not out of bounds for us, like is it inside the grid or outside the grid. So we need to place these checks where we need to check if I is less than 0 or I is greater than board, let's say dot length, or j is less than 0. So I need to put all these checks to see if we are not crossing our boundaries here. And j is this should be greater than equals to, and j is greater than equals to board 0 dot length. Very similar to what we did in our other problem called number of islands. And also one more condition, if we see the word that we are looking at is not the character that we are looking at is not part of this word, then that there is no point in traversing forward and looking in branches of this character. So we can just return from here. So if word dot char hat count not equals to board I j. So if any of these conditions are true, we can just return false. Whew. So we have our breaking conditions ready. Let's see what we can do next. So the first thing we will do is we will increment the count, because if this is not the case, then that means we have found a character in our grid that belongs to this word. Next thing we need to do is we need to make sure that we are not like checking the same letter again and counting it. So what we can do is, in our number of island problem, to solve this, we were submerging that one, so basically making it 0. Here we can convert that character to empty character so that we do not count it again. Let's make it empty character, but we need this word later because this could be part of some other branch. Before doing this, we should create a temp variable and assign it this, so that we can later, after we are done processing, we can assign it back. So this is done, and now we need to check in all the horizontal and vertical neighbors if next character is there in for this word. So we can create a boolean variable called found, and we'll see the next character that we are looking for, is it to my left or to my right or above me or below me. So we'll need to call this word search function again. We can pass it the board, we can pass it the word, we can now we need to check if it is above us, and j will be same and count will be count because we have already implemented it. This is to check if it is above us, the next character. To check it if that character is below us, we can do the same thing. Let me just copy this. In fact, let me just copy this entire thing. We need it 4 times. So or this or this or this. The conditions will be if it is below me, if it is above me, if it is to my left, or if it is to my right. So in all these 4 directions, if we find the next character, then we can just return found. If we do not found it, then found will be false. So let's run it and see if there is some problem with this. If it works. Let's see if we have any problems here. This should be less than, not less than equals to, because it's a 0 index array. And let's see if we missed anything up. So we created this temp variable. Let's assign it back. We don't want to miss this. And I think rest, oh sorry, this should be I. We need to change the j value, not the I value. Big mistake. So let's run it. This looks fine to me. This should work. Let's submit it. It should work, and yep, it passed all our test cases. And so this is how you solve word search problem, a question being asked in a lot of interviews. So if you have any doubt in this problem, or if you want me to solve any other Leetcode or any other coding problem, you can comment that below and I can take a look. And if this was helpful, then you can leave a like and subscribe to my YouTube channel. I'll be making a lot of these videos, and I'll see you next time.